So Iceberg's the hot topic right now. One of the reasons Iceberg was created was because there was this read-based problem where you had to list thousands, maybe millions of files in order to find the ones that were relevant to your queries. Right? It was causing real big problems in Hadoop clusters and other storage mediums and things like that. They solved it by creating hierarchical indexes that for different types of queries and different types of problems narrow down that the file set that you need to solve it. Now, we in Kafka don't have files. Actually, we do, but we can't see them because they're hidden behind the APIs. But what we do have is offsets. What if we were just to treat a block of offsets of an arbitrary given size like it was a file in Iceberg? They're immutable in exactly the same way. We can just say, well, do we need that block? Do we not need that block? And we can drop it, do less read, and hence get speed. Obviously, I'm going to show you the example on the screen with the core use case for Kafka, which is storing pictures of cats. And we can see from this angle, we've got offset 0 to 100 contains only tabbies. And we've created our index that says that. Right? Offsets 100 to 200 contains only gingers. And offsets 200 to 300 contains tabbies with the odd tiger snapped in. By having that index, we now know that if we just want to select out the tigers, we don't need the first 200 offsets. We can skip over them, and we've already just made ourselves a 3x speed up by doing nothing else. Fantastic. And it doesn't have to be just for selection, doesn't have, or anything like that. What happens if we were to, you can really slice and dice these indexes in any way you want once you've decided on this structure of a block of offsets will be referred to by an index. We can add some extra information and say, look, there's 3 tabbies in the first one, 3 gingers in the second one, 2 tabbies and 1 tiger in the third one. Well, if we want to select tabbies, we don't even need to read any data right now, right? We know that we can just consult the index and go, right, so from beginning to end, we've got 5 tabbies. Fantastic, done. Lightning quick. No one yelling at me yet? I do like a good heckle. So, no? Someone at this point, I was hoping was going to be yelling latency at me. No? No. Okay, latency. The trouble is, creating indexes is expensive. Happens asynchronously in the background. So what we end up with is a situation that looks more like this, where we have a cold set, we'll call it. That's a really dodgy term to be using with Kit 405 around, but we have a cold set that's fully indexed and ready. And we have this head of the queue here that hasn't yet been indexed. Right? Could be a major problem for us. We're going to sacrifice latency for the sake of performance on the longer range queries. Yeah, it kind of sucks. But the important thing to remember about this kind of indexing technology is it's acceleration technology. What we're doing, we're not storing the data itself here. No, there's no data. It's just metadata about the data itself that helps us increase performance. So when we encounter a scenario like 200 to 300 here, where we have no indexing information, it's really nice and easy. We just fall back and read it. We just don't get any acceleration out of it. We go, okay, no indexing. I don't know if I should read 200 to 300 or not, so I'm going to. And what that means is you get all the benefits of having your super low latency, really up-to-date Kafka system, but you're able to extend your queries into massive ranges in the past and pull out all of the data that you want.